Think modern technology has surpassed everything the ancient world could create? Think again. While the rest of the world was still figuring out basic metallurgy, Chinese engineers were building machines so advanced that their principles still power our modern world. We're talking about inventions that were literally centuries ahead of their time. Technologies so sophisticated that when Europeans finally encountered them, they thought they were witnessing magic. From earthquake detectors that could pinpoint disasters hundreds of miles away, to mechanical clocks that kept perfect time for decades, these weren't just clever gadgets. They were engineering masterpieces that reveal a level of scientific understanding that was absolutely astonishing for their era. And the final invention on this list achieved material properties that still amaze scientists today. For over 2,000 years, China was essentially running a parallel technological civilization that was centuries ahead of everyone else. While Europe was stuck in what we politely call the Dark Ages, Chinese inventors were creating mechanical computers, precision instruments, and manufacturing processes that wouldn't appear in the West until the Industrial Revolution. The Chinese didn't just invent things randomly. They approached innovation like a military campaign, systematically solving problems with an engineering mindset that combined practical genius with scientific precision. They weren't just making tools. They were building the foundation of modern civilization. Today, I'm breaking down 10 ancient Chinese inventions whose principles and innovations were so far ahead of their time. They still influence how we build, navigate, and understand our world. Let's start with something that seems simple, but was actually a technological revolution that changed human civilization forever. Around 105 CE, a Chinese court official named Kai Lun perfected a paper-making process using mulberry bark, hemp rags, and old fishing nets, beaten to precise consistency and formed using bamboo screen molds. Here's what's remarkable. The best examples of ancient Chinese paper have survived over 100 to 300 years in readable condition. They achieved this durability through sophisticated fiber processing and natural preservation techniques that created incredibly stable documents. The Chinese didn't just invent paper, they invented mass information storage. Before paper, knowledge was trapped on heavy bamboo strips or expensive silk. Paper democratized information and made the spread of ideas possible on a scale that wouldn't be seen again until the printing press. But if you think paper was impressive, wait until you see what they did with printing technology 400 years before Gutenberg. In 1040 CE, a Chinese artisan named Bi Sheng invented movable type printing 4 centuries before Gutenberg. Bi Sheng created thousands of individual characters from clay, fired them to ceramic hardness, then arranged them in iron frames on heated plates using a resinous wax system. The genius was in the flexibility. Unlike expensive metal type, Bi Sheng's ceramic characters could be mass-produced, rearranged infinitely, and lasted for thousands of impressions. The concept was so advanced that it established principles still used in modern printing and digital typography. This technology made books affordable for ordinary people and spread literacy across China centuries before Europe figured out how to make printing economically viable. The psychological impact was staggering. Suddenly, knowledge wasn't limited to the wealthy elite. But the next invention was so mechanically sophisticated, it used principles that wouldn't appear in European engineering until the age of automobiles. Around the 3rd century CE, Chinese engineers built what can only be described as a mechanical computer on wheels. The south-pointing chariot used a differential gear system so advanced that the same principles power every car on the road today. Here's how this ancient navigation system worked. No matter which direction the chariot turned, a figure on top would always point south through a complex system of gears that calculated the difference in wheel rotation and applied counter-rotation to keep the figure aligned. It was a mechanical computer solving navigation problems in real time. The differential gear system it used wasn't developed in the West until the 1800s, over 1,500 years later. The chariot worked without any external reference points, maintaining directional accuracy across hundreds of miles, using only bronze gears and mechanical precision. But if you think mechanical computers are impressive, the next invention could literally predict natural disasters. In 132 CE, Chinese astronomer Zhang Heng created the world's first earthquake detector, a precision instrument that could detect earthquakes from hundreds of miles away and indicate their direction. The Seismoscope was a bronze vessel with 8 dragons holding bronze balls, positioned over 8 bronze toads. Inside was a delicate inverted pendulum system that would trigger when seismic waves arrived, causing the appropriate dragon to drop its ball. In 138 CE, the device indicated an earthquake to the west, when no one in the capital felt anything. Days later, messengers confirmed a major earthquake exactly where the device had indicated. This represents an understanding of seismic wave propagation that was absolutely revolutionary for its time. Zhang Heng had achieved earthquake detection and directional indication using only bronze and mechanical precision, a feat that required sophisticated understanding of physics and engineering. But the next invention revolutionized warfare and exploration, literally changing world history. The Chinese invented the magnetic compass around the 2nd century BCE, developing a sophisticated understanding of magnetism that was centuries ahead of its time. They progressed from lodestone spoons spinning on bronze plates to wet compasses with magnetized needles floating on water. But their understanding went deeper than basic navigation. The Chinese discovered magnetic declination, the difference between magnetic north and true north, and created detailed charts showing how this varied by location. This level of scientific precision was extraordinary for the ancient world. The magnetic compass enabled the age of exploration. Without Chinese compass technology, Columbus, da Gama, and Magellan would never have dared venture into open ocean. The compass literally connected continents and shrank the world. But if you think navigation was revolutionary, the next invention changed the very nature of construction engineering. Around the 3rd century BCE, Chinese engineers were building iron chain suspension bridges using principles of tension and load distribution that modern bridge builders still rely on. They used wrought iron forged into massive chains, anchored deep into rock formations. These bridges were designed to flex and move with wind and seismic activity, while rigid stone bridges would crack and collapse in earthquakes. Chinese suspension bridges would sway and survive through dynamic flexibility, a principle that wasn't formally understood in Western engineering until much later. The fundamental engineering concepts are identical to modern suspension bridges like the Golden Gate Bridge. The Chinese had mastered the physics of tension, load distribution, and dynamic response centuries before these became formal engineering principles. But the next invention was so mechanically complex, it makes precision Swiss watches look simple by comparison. Chinese engineers invented mechanical clocks with escapement mechanisms centuries before Europe developed accurate timekeeping. Su Song's astronomical clock tower, built in 1088 CE, was a 40-foot-tall mechanical marvel that tracked time, astronomical movements, and seasonal changes with remarkable precision. The escapement mechanism that regulated timing became the foundation for all mechanical timekeeping that followed. Su Song's clock maintained accuracy within minutes over months of operation, using only water power and mechanical gears. This level of precision timekeeping was revolutionary. Accurate mechanical time changed how people thought about work, scheduling, and daily life. The Chinese were living by mechanical time, while the rest of the world was still using sundials and estimating. But if you think precision mechanics are impressive, the next invention literally changed the nature of warfare forever. Chinese alchemists discovered gunpowder in the 9th century while searching for an elixir of immortality. But they didn't just stumble onto an explosive mixture. They developed sophisticated chemistry that led to advanced weapons and pyrotechnics. The Chinese weaponized gunpowder with scientific precision, creating the first guns, rockets, landmines, and grenades. By the Song dynasty, they had multi-stage rockets, pressure-activated landmines, and firearms that could penetrate armor. They understood the relationship between chemical composition and explosive power, developing different mixtures for different purposes. Slow-burning powder for rockets, fast-burning powder for guns, and specialized compounds for incendiary weapons. Gunpowder weapons made castles obsolete, ended the dominance of heavy cavalry, and shifted military power to organized armies with superior technology. Every modern weapon traces its lineage back to Chinese gunpowder innovations. But the next invention revolutionized agriculture and fed entire civilizations. Around the 2nd century BCE, Chinese engineers perfected the mold-board plow with a curved blade that didn't just cut through soil. It lifted, turned, and buried weeds while exposing fresh earth for planting. The design was so efficient that it required less animal power while accomplishing more work. This invention enabled intensive agriculture that could support large populations. The mold-board plow made it possible to cultivate heavy, fertile soils that had been impossible to farm effectively, supporting the population growth that made Chinese civilization possible. The basic principles perfected by Chinese engineers over 2,000 years ago remain unchanged in modern agricultural equipment. Tractors and contemporary plows are essentially mechanized versions of ancient Chinese designs. But the final invention on our list achieved something that still amazes material scientists today. Chinese artisans perfected porcelain in the 7th century CE, creating a material so advanced that European alchemists spent centuries trying to discover its secrets. True porcelain required specific kaolin clay fired at temperatures over 1300 degrees, creating material that was white, translucent, incredibly strong, and completely non-porous. The techniques were so closely guarded that they remained Chinese secrets for over 1,000 years. The finest examples of ancient Chinese porcelain demonstrate a combination of strength, beauty, and durability that represents the pinnacle of ceramic achievement. When Europeans finally learned porcelain production in the 8th century, it sparked advances in chemistry and material science that contributed to the Industrial Revolution. The material was so superior, it became known simply as China. These 10 inventions reveal that Chinese civilization was conducting systematic research and development centuries before the scientific revolution. Each invention represents scientific understanding and engineering precision that was extraordinarily advanced for its historical period. What makes these inventions remarkable isn't just their individual brilliance, but how they built upon each other. Paper enabled knowledge spread that led to better engineering. Mechanical clocks provided precision timing for advanced manufacturing. Gunpowder changed the entire nature of human conflict. The Chinese approach was systematic and scientific. They methodically solved problems through experimentation, documentation, and continuous improvement. Modern engineers studying these ancient inventions consistently find elegant solutions that establish principles still used today. These 10 ancient Chinese inventions prove that technological advancement isn't just about modern materials or computer-controlled manufacturing. It's about understanding fundamental principles and applying them with precision and creativity. Working with bronze, iron, clay, and wood. Chinese inventors achieved results that established the foundation of modern technology. They understood physics, chemistry, and engineering at a level that was centuries ahead of their time, creating innovations whose principles continue to influence our world today. If you thought these ancient inventions were impressive, wait until you see the military technologies that made Chinese armies unstoppable for centuries. Click here to discover the siege engines, weapons, and tactical innovations that gave Chinese forces technological superiority that lasted for millennia.